Hello, Algebra and Honored Algebra students. Mr. Lawrence here, and we are going to continue with our exploration of volume, and we're actually going to throw surface area in this one as well. Okay, now on the formula sheet you're going to get for the OAA, it's going to say the volume of a right prism or volume of a cylinder. It's going to go capital BH. Okay, now before I explain what all that is, I want to explain to you the way I think about a 3D shape. You see, I don't see a cylinder as two circles and a rectangle most of the time, or two circles and a body. I see a cylinder as a whole bunch of circles stacked up on top of each other. For example, if you had some poker chips or maybe some quarters or something else like that, and you stacked a whole bunch of them up, you would make a cylinder, wouldn't you? Now, a really cool thing is, the way to think about this, and you see my cylinder, even though it doesn't look perfect, you can see the idea of what I'm getting at. If I can figure out the area of this bottom circle, or this base circle if I want, and I'm going to shade it here, we're going to make it a solid fill, and I'll make it blue. If I could figure out its area, and I could figure out how many of them were stacked up, I would be able to tell the space inside of the 3D shape. Remember, that's what volume is. It's the space inside a 3D prism or cylinder or anything like that. Okay, volume is the amount of milk a carton can hold. Volume is the amount of gas that a gas tank can hold. Things, okay? So, I know that the base of a cylinder is a circle. Well, to find the area of that, I use pi r squared, right? And then what would tell me how many circles are stacked up on top of each other? Well, think about it. Look at this distance here. What is that? Well, that would be the height, of course. Yeah, so I could take the area of the base and multiply by how many circles there are, or how tall it is. And that would give me the volume of a cylinder. Okay, capital B stands for area. Oops, that doesn't look like area, sorry. Area of the base. And that's what capital B is. H is the height of the cylinder itself. Now, not surprisingly, I think of a triangular prism as a whole bunch of triangles stacked up on top of each other. I think of a pentagonal prism, and I know some of you are pentagonal prism. What the heck is that? Well, let's see here. Let's see if I can. I don't know if I can get the right angle or perspective with this one as I did with the other one, but if I were to clone him infinitely, and then, yeah, that kind of looks right. You can see I'm getting a pentagonal prism. The base would be a pentagon. It would be like a whole bunch of pentagons stacked up on top of themselves. Okay? If I could figure out the area of the base, multiply by how many pentagons there were, which would be the height of the prism, I could figure out the volume of the shape. So let's give it a shot here. Okay? So here we have a cylinder. We know it has a diameter of 38 inches. It looks like I forgot to tell you the height of the cylinder. We're going to make the height 40 inches. Okay. I know the diameter is 38 inches, right? Consequently, that makes the radius 19 inches. You should know a radius is half a diameter. If you ever get them confused, a radius is a bicycle spoke. Okay? Not a diameter. A radius is the bicycle spoke. So, the formula says to do the volume of a cylinder, I'm going to do capital B times H. Well, the base is a circle, so that means I'm going to do pi r squared. That'll get me capital B. What I've been doing with my pre-algebra kids, and it seems to work really well, is they are taking some type of light pencil or something, and they're shading in the base. They're finding that area, that's capital B, and then they're just multiplying it by the height. They seem to really like doing it that way. If it works for them, you're having trouble, then please give it a shot. So this will be 3/1400 times 19 inches, and I'm going to square that. Okay, then once I have that, I have to multiply by how tall the cylinder is, and that, of course, in this problem is 40 inches. So I'm going to get the capital B. Hold on a second here while I get my calculator booted up. Okay, I think I'm in the right place. I had been talking for several minutes and the video was not recording. So anyway, what I think happened was I went to go show you on the calculator what I would get. I want to point out to you that this number here is the capital B. You see it's the pi times the r squared. It's this green part. And then when I multiply by the height, I get 40 inches squared. So there is the volume of the cylinder, and I hope there's not a break in continuity there. I do apologize if there is. 45,341 and 6/10 inches cubed, because right here I have inches squared, and then I have multiplied by another inch. So I have inches times inches times inches, essentially. All right, let's come on down here to a rectangular prism. And the prism has to have a base of a rectangle. It doesn't matter on a rectangular prism which side you call the base, because any one of them could be. It doesn't have to be the face it's sitting on. I will go ahead and just call it this. All right, this rectangle I'm trying to highlight in here. This is the area of the base. And got to get back in pen mode. So the volume of the prism is going to be capital BH, and I'm going to do 6 centimeters times 40 centimeters. And then I'm going to multiply by the height of the prism, which is 10 centimeters. I don't think I need a calculator for this. 6 times 4 is 24. So 6 times 40 is 240. And then times 10 would be 2,400. Centimeters times centimeters times centimeters is centimeters cubed. And so there's your volume right there. All right, now this is a triangular prism, which most of you can identify, although some of you will try to tell me the base is the side it's sitting on. No, 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 no. I don't know how many times I can tell you. The bases in a prism, one, they're hidden in the name. Rectangular prism, the base has to be a rectangle. Triangular prism, the base has to be a triangle. Okay. Also, the bases have to be parallel to each other. I can show you a triangular prism at school. There are no rectangles parallel. There's a rectangle here sloping down like it's a ramp. There's one here that's like the back of the ramp. And there's one here that's like the bottom of the ramp, you know, touching the ground. None of them are parallel to each other. In a prism, they have to be parallel. All right, so here's what we're going to do. We're going to use the same formula. Capital B, H. Now remember, this H is the height of the prism. Because capital B, triangle, it's going to be base times height, and it's the height of the triangle. Cut it in half, and then I'm going to multiply it by the height of the prism. So, here we go. So, the volume is going to equal 9 times, it's 9 feet, times 12 feet. Going to divide that by 2. And we're going to multiply that by 20 feet, because 20 would be the height of the prism if it was resting on the base. Okay? Now, you know, Mr. Lawrence, I like to divide before I multiply, if possible. So there we go. 9 times 6 is 54, and 54 times 2 is 108. 54 times 20 is 1080. Feet times feet times feet is going to be feet cubed. So there's your volume right there. All right, so that's volume. Now there's still volume of cones and pyramids, and I will show that to you at another time. I'll probably demonstrate that in class, but let's talk about surface area. So let me pause my video here. Okay, so to do surface area, all surface area is literally, you guys like to give that smart aleck answer where you just use the words to define the word. Well, you can with surface area. It's the area of the surface. The surface area is the amount of skin it takes to make your body. Surface area is the amount of aluminum it takes to make a can of pop. Okay, on the outside. The minimal amount of wrapping paper to cover a present. It must be fully covered. Okay. Well, when I look at a rectangular prism, what I see is, I see 6 rectangles. Well, to do surface area, one way I really like to do it is to draw out the shapes. So here's the bottom, and it's going to be 6 by 40, right? Now, the top is going to be exactly the same, so I'm going to multiply its area by 2. So I'm going to go 6 times 40, which is 240 centimeters squared, right? Hold on, it didn't look very neat here. Centimeters squared. All right, so I'm going to go 240 times 2, and that'll get me 480 centimeters squared. Now that's only part of the surface area. That's the bottom and top of the box. I see another set of rectangles in there. I see the left and right side, and they kind of look more squarish. They're not squares, but they kind of look like this. And I think the dimensions there are 10 by 6. And if you like, I can highlight the two I'm talking about. Let's get a highlighter out here so you can see specifically. Okay, I'll be talking about this side here. And of course, its matching partner over there. Okay, so it's 10 by 6. So I've got 10 this way and 6 this way. And again, there's 2 of them. So I know this area is going to be 60 centimeters squared. Multiplied by 2 will be 120 centimeters squared. All right, and I'm underlining those for a reason. Finally, there's the front and the back of the box, which I haven't accounted for yet. Let me move my highlighting out of the way and get another highlighter out here. Okay. So this rectangle, which appears to be the front of the box, there we go. Looks like it's going to be 10 by 40. And of course, it would be the same back here. So front and back. Okay, so that's going to be 10 by 40. So let me get that rectangle drawn. And 10 by 40 will be 400 centimeters squared. And again, there are 2 of them, so that'll be 800 centimeters squared. Now, to get the true surface area, I have to add up all those areas. So let's see, it's going to end in 0. It's going to have another 0, going to carry the 1, 12, 13, 14. It looks like it's going to be 1,400 centimeters squared. And there you go. That is going to be the surface area of that rectangular prism. Okay, the triangular prism, hold on, let me pause this. Okay, so we're going to break down this triangular prism. And of course, I know this triangle here is 9 by 12, and there's two of those. So I'm going to draw the triangle. Okay, and I know it's 9 by 12. And its area is going to be 9 times 12 divided by 2. And there's going to be two of them. Now, if you want, you could just cancel out the 2's and just do 9 times 12, which I believe is 108 feet squared. Okay, so that's fine. Now, what's tricky for some kids is there's going to be 3 different rectangles. The only reason you won't have 3 different is if you have like an isosceles triangle, then 2 of the rectangles will end up being the same. If you have an equilateral triangle, then all 3 of the rectangles will be the same. So I'm going to have 3 different rectangles. So let me draw 3 different rectangles, and I'll see if I can label them correctly. There's 1, 2, and 3. And it doesn't really matter which ones I call which. I'm not going to have to multiply because, like I said, they're all different. It looks like one of them is going to be 20 by 12. So 20 by 12, and the area of that will be 240 feet squared. Okay, so I'll write a 240 over here. Okay. Another one appears to be 20 by 9. 9 by 20, which is 180 feet squared, 180 feet squared. Now, the other one, I don't have enough information because I know it's 20 feet, but I don't know what this dimension is. Well, what do I have there? A right triangle. You guessed it. I'm going to go to the Pythagorean theorem. A squared plus b squared equals c squared. Most important side is c. I'll fill that in. How did I know it was x? Because it's across from the right angle. All right. A squared is 9 squared. B is 12 squared. It's going to be 81 plus 144. Which equals x squared. X squared is going to end up equaling 225. X will equal 15 when I take the square root of both sides. So this final rectangle is 20 by 15. So 15 here, 20 there. So it'll be 300. So I'll have 300 feet squared. Add them all up. What the woo-da-wah was that? Uh-oh. It doesn't appear to be responding properly. Okay, so let's add it all together. Feet squared. All right, we're going to get an 8 there. We're going to get 12 there. Carry the 1. And we got 3, 4, 5, 8 more. 828 feet squared. Now, the last one we're going to do for now is the cylinder. Now, the cylinder is really cool, and I can show you this in class if you like. First of all, you're going to have pi r squared for the circle, okay? And there's going to be 2 of those. But we're going to need the body of the cylinder. The body of the cylinder is a rectangle in disguise. And I can show you this, or you can take a piece of paper and roll it up. This part here would be the height of the cylinder, right? So that's 40. That's no problem. But how would you get this part here? Well, wouldn't that be the distance around the circle? Or in other words, the circumference. So we're going to find the circumference, and circumference equals pi times the diameter. So we're going to have 2 pi r squared plus pi times the diameter. Now, I think on a formula sheet, you might see it as 2 pi r squared plus 2 pi r. If that helps you remember it better, go ahead and do it that way. I'm going to use pi times diameter because that's how I think of circumference. All right, now I know my radius is half of this. The diameter is 38. The radius is 19. So I'm going to have 2 times pi. And again, 3.14 is not pi. It's only an approximation. Times 19 squared plus 3.14 times 38. Okay, well, I can go to my calculator and do this. Hold on one second. Let's get it back up here. And let me clear this off so it's not in our way. And I'm just going to type in exactly what I wrote. 2 times the quantity of 3.14 times the quantity of 19 squared plus 3.14 times 38. And there you go. I'm going to get 2,000. Where am I? 2,386 and 4/10. I forgot my units. I know they're squared units. I'm in inches. Inches squared. Okay, now like I said, the formula sheet is going to have all this on it for you, but you have to know how to use it. Okay? All right, that's it for this video. We'll talk to you later. Mr. Lawrence signing off. Have a good night, everybody.